Rivers are systems for moving water downhill. The river system is divided into three main parts: the upper course, the middle course and the lower course. The start of the river is in the upper course. This is called the source of the river. The upper course is steep and a long way above sea level, and the river has lots of energy for erosion. When rivers have spare energy, they can erode their river channel and also transport material along with them. There are distinctive landforms in the upper course, such as V-shaped valleys and waterfalls. In the middle course and the lower course, the gradient is not so steep and the river is closer to sea level. In the upper course, the channel is rough and narrow and friction slows the river down, but in the middle and lower course, the channel is wide and smooth and the water flows faster. One way the river system copes with the extra energy is to meander. The flow of water winds through the valley, eroding on the outside of the bend where the water flows fastest, and depositing on the inside where the river flow is slower. This makes its channel wider, and it also erodes the valley sides, making the valley wider. The meanders slow the river flow down, and if a large input of water comes into the system suddenly, there may be too much water for the channel to process and floods occur. When they don't have enough energy to erode and transport, rivers drop material. This is called deposition. So as the water spreads out over the floodplain, it loses energy and deposits its load. The mouth of the river is where it meets the sea. New water doesn't get created. The amount of water in the world has been the same for millions of years, but water does change its form and where it's stored. Some water is stored as ice in the polar regions and glaciers or in underground aquifers, but the vast amount of the world's water is stored in the sea, 95%. The hydrological cycle is a cycle. It doesn't have a start or an end, but we can start looking at it with evaporation, which is when the sun's heat changes liquid water into water vapour. This happens at the surface of the sea and from water surfaces on land. Evaporation is the main way that water vapour enters the atmosphere, but transpiration is another way too. This is when plants breathe water vapour into the air. Warm air can hold more moisture than cool air. When the water vapour in the atmosphere is cooled, it forms liquid water again. This is called condensation. It is this process that creates clouds. The water droplets formed by condensation fall as precipitation: rain, sleet, snow, hail. Some falls back into the sea, some onto the land. When precipitation falls onto the land, the water starts its journey back to the sea again in a process called runoff. There are a number of different ways it does that. Overland flow, or surface runoff, is when the water runs over the surface of the ground until it reaches a stream or river or the sea itself. When the water enters the ground, that is called infiltration. The water percolates downwards through the soil and rock until it reaches groundwater. Through flow describes the flow of water through the ground in a layer between the surface and the groundwater store. Groundwater flow is the flow of water through the groundwater store, underground, to rivers and then to the sea. Rivers erode material from their channels. They transport material and they deposit material. There are four main ways rivers erode. Four main ways rivers transport, but only one way they deposit material, when they don't have enough energy to transport it anymore. Erosion is the wearing away of the riverbed and banks. The four main types of erosion are hydraulic action, abrasion, attrition and solution. Hydraulic action is where water forces air into cracks and holes in the rock and soil, helping to break them up. Abrasion is when the rocks and stones that are carried along by the river bash into the bed and banks, wearing them away. Attrition is when the rocks and stones carried by the river wear each other down as they bash into each other. Solution is when particles from the rocks and soil of the riverbed and banks get dissolved in the river water. Transportation is when the river carries material along with it. Like erosion, this takes energy, and if the river loses energy, for example if the water flow is slowed down by an obstacle, the river may deposit the material it was transporting. There are 4 main types of transportation: traction, saltation, suspension and solution. Traction is when large boulders are rolled along the riverbed. Saltation is when small boulders and rocks are bounced along the riverbed. Suspension is when lighter, smaller bits of rock and soil are carried along in the flow of the river. Solution is when material is dissolved in the water and carried along with it.
Okay, let's have a think about how river erosion processes work. Here we've got the cross-section through a river channel, and we've got the 4 main methods of erosion highlighted on the diagram. Let's talk about each one in turn. First of all, hydraulic action. As you can see, hydraulic action is pointing to these cracks on the riverbank and the riverbed. You can see. What happens is, as the water moves over this crack, or especially as the river flow, if it's quite high or quite fast, then the pressure inside this void, inside these cracks, is increased. Over time, as the pressure increases again and again, these cracks start to widen and start to break off bits of the riverbank and bits of the riverbed. And these fall into the river and they become sediment or load for the river. Next up, you can see abrasion. This load, in other words, the sediment that's in the river channel that might have been brought into the river channel by hydraulic action or some other method, these stones, these rocks, they can bang against the banks of the river, against the bed of the river, and as they do, they might wear it away, physically break off chunks. Our third one is attrition. And you can see at the bottom of this diagram, quite a few of these rocks and stones, they're quite rounded. Now that might be because the rocks themselves have been subject to attrition, which is the process where the stones themselves roll against the banks of the river, or the bed of the river, and against each other, and therefore they become rounded and they become smaller. So you can see, for example, this one here has become more rounded than this one here, and it's smaller. That means attrition might have worked on it more. So attrition is a process that works on the actual sediment and not the actual banks or the bed of the river itself. Lastly, we have solution. And as you can see here, solution, there isn't actually anything next to the word solution. That's because it's the chemical action of the water on the rocks and the minerals in the banks and the bed of the river. This means that very small particles dissolve and are carried along without being seen, basically. So solution is the chemical action of the water on the river structure. And this means that solution is the one of the 4 that will work no matter what the conditions of the river are. If it's in flood or if it's in very, very low flow, solution will work all the time, whereas the others, attrition, abrasion and hydraulic action, all work more when there is much more water and therefore more energy in the river. Thank you.